Welcome students in this Skylar tutorial. In this lecture, we'll be going to learn to find out group number and period number of the given elements in the modern periodic table. So let's begin. So before going into the topic, let me first give you all a brief idea regarding the modern periodic table. It was given by Sir Henry Moseley, which consists of 7 periods and 18 groups. So the horizontal rows are known as periods and the vertical columns are known as groups. According to the syllabus of class 10th, students should be crystal clear of the elements up to the atomic number 20, that is up to calcium. From hydrogen, that is atomic number 1, to calcium, that is atomic number 20. Now let's come to find out the period number. So we must first keep in mind that period number is equals to number of shells, right? So according to Bohr's postulate, we know that Bohr had given the number of shells, means he named number of shells as K, L, M and N respectively, right? The first shell represents K, the second shell as L, the third is M and the fourth as N. Now let's understand by taking an example. For example, suppose we have an element carbon. We know that carbon has atomic number as 6. So its configuration can be written as 2 and 4. Here the carbon took 2 shells, that is KLN, that is 2 and 4. So its period number will come out to be as 2. The next example, suppose magnesium. Magnesium has atomic number 12. So its configuration can be written as 2, 8 and 2. It took K, L and M. So its period number can be 3. The another example, let's take of aluminium. Aluminium has atomic number 13. So its configuration can be written as 2, 8 and 3. It took 3 shells, that is K, L and M. So its period number will be 3, right? The another example we can take of fluorine. So the atomic number of fluorine is 9. So its configuration can be written as 2 and 7. It took only 2 shells, that is K and L. So its period number will come out to be as 2. Now moving on to group number. Since we know that period number represents number of shell, here group number represents number of valence electron. That is, group number equals to number of valence electrons. Now you all must be wondering, what is valence electron? Let me make it clear to you all. Valence electron is the electrons present in the outermost shell of the element. Let's take an example of carbon. Carbon has atomic number 6. So its configuration can be written as 2 and 4. Here, carbon and N. So here, in the first shell, carbon will have 2 electrons, and in the last shell, it will have 4 electrons. So, valence electron represents the electron of the last shell. So, carbon will have valence electron as 4. Now, you all might be clear about the valence electron. So, let's move on to group number. The easy way to find out group number is to keep in mind the following 2 conditions that I am writing here. Condition number 1. If valence electron is 1 or 2. If valence electron is either 1 or 2, then group number will be 1 or 2 respectively. There is no problem. If the valence electron turns out to be 1, then we'll easily get that the group number will be 1. And if the valence electron is 2, then the group number will definitely be 2. But in the condition number 2, in the second condition, if valence electron is 3 to 8, if the valence electron is in between number 3 to 8, then the group number will be 10 plus the valence electron. This is the very important point that we must keep in mind, that if the valence electron is 1 or 2, then there is no doubt the group number will be 1 or 2 respectively. But if the valence electron is either 3, 4, 5, 6, 7 or 8, then the group number should be equal to 10 plus the given valence electron. Will be more clear when we'll get the example. So let's take the following example of sodium. Sodium has atomic number 11, so its configuration can be written as 2, 8, 1. So here its valence electron is 1. So group number will be 1. Let's take another example of magnesium. Magnesium has atomic number 12. So its electronic configuration will be as 2, 8 and 2. Here valence electron is 2. So group number will be 2. No doubt. Condition 1 is followed over here. Now let's take an example of aluminium. The atomic number of aluminium is 13. So its configuration can be written as 2, 8 and 3. Look over here. The valence electron is 3. So condition 2 is followed. That is 3 to 8. Then its group number will be 10 plus the valence electron, that is 3. So its group number will be 13. So aluminium belongs to the 13th group, magnesium belongs to the second group and sodium belongs to the first group. Let's take another example to get it more clear. Example of chlorine. We know that chlorine has atomic number 17. So its configuration can be written as 2, 8 and 7. Here valence electron is 7. So condition number 2 will be followed over here, that is in between 3 to 8. So group number will turn out to be as 10 plus 7, that is 17. So we can clearly say that chlorine belongs to group 17. I hope that you all have understood it very well. Thank you for watching.